Hello good people, I would like to talk about Keto-enol Tautomerism. It is a conversion of a keto form here on the left into an enol form on the right. A keto form is any aldehyde or a ketone that also happens to have an alpha hydrogen. What do I mean by that? Well, this carbon here with the yellow dot, that is the carbonyl carbon. The carbon next to it is an alpha carbon. Any hydrogen attached to it is referred to as an alpha hydrogen. So generally speaking, you could say that as we go from a keto form to the enol form, the alpha hydrogen ends up as a hydrogen on the oxygen here, giving us the alcohol functionality. And this bond in green, the bond between the alpha carbon and the alpha hydrogen, ends up as a bond between the two carbons. Finally, you could also say that this bond in orange, so the pi bond between the carbon and the oxygen of the carbonyl group, ends up as a bond between oxygen and hydrogen. Once again, this is just generally speaking, not necessarily what happens when we think in terms of reaction mechanisms. And I will now talk about the reaction mechanism under acidic conditions. So let me just scroll down a little bit. Here's my starting material. I have chosen ethanol, an aldehyde, but it could have also been a ketone. I have said that this happens under acidic conditions. So here's my protonated water. What is the first step? The lone pair electrons of the oxygen will be attracted to the hydrogen of the protonated water. The electrons between that particular hydrogen and oxygen will end up on the positive oxygen. And we will get an oxonium ion and a water molecule. What is the next step? Remember, we need to get to an enol form. We need to get to an alcohol and a double bond. The pi electrons between the carbonyl carbon and the oxygen will be attracted to the positive charge on the oxygen. The electrons between the alpha carbon, and let me label that one again, so there is my alpha carbon, and I'm also going to number them. So this is 1 and this is 2. All right. The electrons between the alpha carbon and the alpha hydrogen will end up as the pi electrons or pi bond electrons between carbon 1 and 2, while the oxygen lone pair electrons on the water will be attracted to the alpha hydrogen. And so we will end up with an enol form. So we have an alcohol that is also attached to a carbon that is part of a double bond. So we have an enol and we have a protonated water. Remember that I said that we can go back, so we can go from a keto form to an enol form, and we can go from an enol form to a keto form. How does that look in terms of the reaction mechanism? Well, we need to recover the oxonium ion again. So the lone pair electrons of the alcohol will go back down to form a pi bond between the oxygen and carbon number 1. The pi electrons, the pi bond electrons between carbon 1 and 2 will be attracted to one of the protons on the protonated water. And the electrons between that particular hydrogen and the oxygen on the water will end up on the oxygen. And that brings us back to our oxonium ion and our water. What is the next step? Recall, we are trying to get back to our aldehyde. So we need to get a carbonyl group. Or, if you like, we need to get rid of this proton here, this one in yellow. So that means that the electrons that make up the bond between the oxygen and the hydrogen will end up on the oxygen of the carbonyl, and the lone pair electrons of the oxygen on water will be attracted to this proton here in yellow. And when all is said and done, we are back at our ethanol, and we have also recovered our protonated water that helped us start the whole process in the first place. So that is all for now, and I will see you on the flip side.